So we are given this circuit. Ignore mutual inductance between the inductors. So mutual inductance we can ignore. So it makes our problem simpler. The current I in the middle wire reaches its maximum magnitude I max at time t equal to tau. So the I becomes I max at t equal to tau. Which of the following statements is true? So there are 4 options given. So in fact we have to find value of I max from the options we can see, and we have to find tau. Okay, expression for tau, expression for I max we have to find. Now let's analyze the problem. It says at t equal to 0, these and these are closed. When they are closed, current will start flowing here because now the circuit is closed. Now see, if the current from here, if we call it I1, this current will go here, it will reach this junction. Now the question comes, it may come to your mind, whether the current will divide, one part will go this way, one part will come this way. Will that happen? Just think. See, this is directly connected to this point. But on this part, there is a resistance and there is an inductor. So there is some resistance there. Means there is some obstruction there. So obviously the current here, this current I1 will not go this way. The whole of I1 will come this way. Clear? This you must realize. Some students will get confused there because they will use Kirchhoff's junction rule. So I1 is coming to this junction, a part will go there, a part will come here, then they will get nowhere. Okay? So you understood that I1 will come this way, downward. Okay? Now let's think about I2. If we call this current I2, this I2 will reach this junction. Now what will happen? Again the same situation like this, it will not bifurcate because there is some obstruction here, there is no obstruction here. So whole of I2 will go from this point to that point. Then it will go in this path. Okay? So I2 will go from top to bottom. So I will be equal to I1 minus I2. I think you have understood this. I1, direction of I is given to be coming down. I1 is coming down, I2 is going up. So I will be equal to I1 minus I2. Clear? Okay. Now, we have to find the maximum value of I, which is called I max, which happens at time t equal to tau. Now think about which is this topic. Is it normal current electricity? Chapter 3 of NCERT book, class 12? No. Here there is an inductor and a resistor. So this is growth of current in an inductor. That topic which comes in AC. The topic here is growth of current in an inductor, which I think doesn't come in NCERT 12 syllabus. This topic is included in JEE advanced syllabus. Okay, I believe this is an extra topic. Okay. So what is the formula for that? Growth of current in an inductor. I is equal to I naught 1 minus e to the power minus t by tau. This is the equation for that. Okay. And this tau, this is a time constant. Tau is equal to L by R. In a normal RL circuit, tau is equal to L by R. So these are the formulas we have to apply here. And then what is I naught here? I naught is the maximum value of the current. Once the current stabilizes in this circuit, so this is DC, this is a cell, so this is direct current. So for direct current, after it has grown to this maximum value, this will not offer any resistance. So the current here will be V divided by R. So I naught is V divided by R. Similarly, here also, once the current reaches its maximum value, the value of I naught here, that is the maximum value, will be V divided by R, because this will not offer any obstruction. Clear? That means the maximum current in both these circuits, both these portions will be the same, V by R. Clear? Now let's come here. I equal to I1 minus I2. This implies I equal to I1 will be this current here. I naught is V by R, 1 minus e to the power minus t by tau. Tau is, this is L by R, so this is L, this is R. This will be L by R. Okay? Minus for I2, this will again be V by R into 1 minus e to the power minus t by tau. Tau for this one will be 2L by R. So this will be 2L by R. Okay? Because here the inductor is given to be twice L. So if we take V by R common, we will get I equal to V by R 1 minus e to the power minus R t by L. R I have taken upwards, minus 1 minus e to the power minus RT divided by twice L. As you can see, this one will cancel out, so we will get V by R. This will become positive e to the power minus RT by twice L minus e to the power minus RT by L. This is I. Okay? Now we have to find the maximum value of I at a particular time, which is given to be tau. Don't confuse this tau to be this tau. This is a different tau. In the equation it says I reaches its maximum value at t equal to tau. Now what we do is we have to find the maximum of this at particular time. So what we do? We use differential equation, those maxima minima theorem. Clear? So we differentiate it with respect to time. So di by dt, how much it will be? V by R, differentiation of this, so minus R by twice L, e to the power minus RT by twice L, minus, this will come, this minus minus will become plus, this will become R by L e to the power minus RT by L. Right? So at maximum, what will happen is this will become 0. So we have to equate it with 0. So when equate it with 0, so obviously V by R cannot be 0. So this has to be 0. So that means we will have minus R by twice L e to the power minus RT by twice L plus R by L e to the power minus RT by L equal to 0. See, this R and this L will cancel out. I can omit it. This 2 I can write here. So this will be 2 e to the power minus RT by L. If I transfer this to that side, it will be e to the power minus RT by twice L. Okay? This is happening when I is maximum, that is when time is tau. So instead of t here, I can write tau here, this tau. So if we take ln on both sides, this will be ln2 plus ln of this, that is minus r tau by L, ln of this minus r tau by twice L. So implies ln2 equal to, if I transfer it there, this will be r tau by L minus r tau by twice L. This is half of that, so this will be twice L. This will be r tau. So that means tau will be equal to twice L by r ln of 2. So twice L by r ln of 2, this is option D. So option D is correct. So one correct option here is option D. So obviously, so option C is not correct. Now we have to find I max. That means when tau is equal to this, we have to find the value of I. And the value of I we had found out to be V by R into this much. So this will be V by R e to the power minus RT by twice L minus e to the power minus RT divided by L. So when the current is maximum, the time is tau. So instead of T, we have to substitute e to the power minus R by twice L. T is tau. The value of tau we have found out to be twice L by R ln of 2 minus e to the power minus R by L. T is tau, I have found out to be twice L by R ln of 2. So if you simplify it, what we get? R cancels out, 2L cancels out. So this is V by R e to the power minus ln of 2 minus e to the power minus twice ln 2. This we get. So if I do keep on doing this, so this will be e to the power ln 2 minus 1 by e to the power ln 4. So this will be V by R, this will be 2, so this will be half minus this will be 1 by 4. So that this will be 1 by 4, this minus this. So this will be, this will come out to be V by 4R. So V by 4R is option B. So option B is correct. So the correct options for these questions B and D. Clear? This question is long, difficult, and the concept is also an advanced concept. So I will rate it as a difficult question. Calculations are also lengthy. Concept is also advanced. You have to use differentiation. You have to find the maximum. Okay? But if you proceed step by step, systematically, you go and end up at the answer. Okay?